All right, so I just want to go through these things. So there's three types of decimals. Three types of decimals that we want to talk about. So there's recurring decimals, which have an infinite number of decimal places. They never come to an end, but it's either one number repeated or there's a repeating pattern. This is a type of rational number. Then there's terminating decimals. Terminating decimals have a finite number, as in have a set number. They come to an end, and you can, again, they're a rational number. You can write them as a decimal. So, for example, 0.85, 0.1, 0.54345. You can have 100 decimal places, but there's a limited number of decimal places. The last one is non-recurring, non-terminating. So it never comes to an end, and there's no set pattern for the whole. And that's irrational. You can't write those numbers as a fraction. So things like the number, the pi that we use when we're doing a circle, pi 3.14, ... goes on forever. It's an irrational number. The square root of 2. Square root of 2 is an irrational number. There's no number that you multiply by itself. So you can write as a fraction that multiplies to go to 2. They're irrational. Yes, John.
We have to write those three types of decimals.
Could you just jot down quickly what they are? Okay, so three types of decimals. And the main point is these two, recurring and terminating, are rational. You can write them as a fraction. But the last one's irrational. And now just very quickly, it's also, I just want to, before we go to the main thing, to express a fraction as a decimal, all you do is divide the numerator by the denominator. Of course, the calculator will do it for you. You type in the fraction, and then once you press equals, and then you press the fraction button, it will go between fraction and a decimal for you. But if you want to do it manually, you divide, you can do long division, you divide the numerator by the denominator. So for example, 3/4 equals 3 divided by 4, which is 0.75. So 1 second go. Or to express a decimal as a fraction, you make it a fraction over 100, or 1,000, or 10,000, depending on where it is in the decimal place, and then you simplify. So for example, 0.4 is 4 over 10. So it's 4 over 10 because it's 4 tenths, which you then simplify to 2/5. Then 0.74 is 74 over 100. If there's 4 hundredths, there's 7 tenths, it's 7/400, so it's 37 over 50. But again, when you type in the decimal and press the fraction key, you will convert between it. You get more familiar as you do more and more. Yes, John? Oh, no, it can't be. Right, so to convert from a fraction to a decimal, you just divide the top by the bottom. To go from a decimal to a fraction, you have to look at the decimal place values and think how many tenths are there, or how many hundredths, or how many thousandths. And put that over that number, and then you simplify the fraction. Yes, no worries. Okay, so that's very quickly how you go between fractions and decimals. And so it's a very simple operation, as long as it's a terminating decimal. As soon as we have a recurring decimal, it becomes, and that's what we're going to look at now. All right, so I'd like to just show you a few methods. That clearly not help. Alright, so once you finish writing that, I'm going to show you this other method of converting recurring decimals into fractions. Can I move it up to here? Just writing it. Just go back to it. Okay, we're going to move it on in a moment. I want to get through, mindful of the time as well. Okay, so just come back to it, that's fine.
Just to the last decimal.
That's that's fine. Just leave it. I can come back to it afterwards. I really want to get through this stuff. So when comparing the values of fractions and decimals, you need to convert them to the same things. It's very difficult to convert the value or to compare the value of a fraction and a decimal. So the easiest thing is to convert them both to decimals and then see which is bigger. How's that? Okay, so leave some space and write converting recurring decimals to fractions. Okay, so recurring decimals are rational, so it can be written as fractions. But you can't put a recurring decimal into a calculator. There's no way to put 0.1, and then you press a button and it'll change it on most calculators. There are some which can do it, but the ones that most of us have don't do that. And so we need to have a way to convert between recurring decimals and fractions. Okay, now this method is reasonably simple in the way that it works. And it's quite a clever method, but it is a little bit tricky. So a lot of students can have problems the first time around or looking at it or trying to understand. I think one of the main reasons is because it involves a little bit of algebra that we need to use and understanding what we're doing. Okay, so it involves cancelling out the repeating part of the decimal by using some simple algebra. Okay? And so once you've written down to here, I'd like you to just watch the examples that I do, and I'll give you time after each one to write it down. But I really want you to just listen to what's happening and what I'm doing on the board. Okay? Right? Don't tell me, right? The first one we have here is 0.11111 repeater. Okay, so it goes on forever at 0.1. And I'm thinking, well, how do I write this as a fraction? So this is the method that we're going to use. So we say, well, let's give this 0.11 repeater a name. All right, we're going to label it as something. The name I'm going to give it could be any letter. I'm just going to call it n. So I'm going to say n equals 0.1111. Okay, you could use the repeater sign. I like to write it out a few times because the reason I'm showing now. Yes. Now, what I'm going to do next is I'm going to say, well, I want to cancel out this repeating part. What happens, somebody tell me, what does it equal when I multiply this number by 10? What do I get? When I multiply 0.1 repeated by 10, what do I get, Jar?
1.11.
Yeah, 1.1. So that's 10n. 10 times n equals 1.1111 repeated. Okay, so now I have n, which is 0.1 repeater. I have 10n, which is 1.1 repeater. Now what I want to do is cancel out the repeating part. So what I'm going to do is, over here, I'll just continue it. You got... Don't worry, I'm going to ask IT to fix this. After this lesson. Okay, so what we have is 10n minus n equals, what happens when I subtract, just before I look at the 10n's, what happens when I minus 0.1111 from 1.1?
You get 1.
You get 1, because the 1 it cancels, When I subtract it, it cancels, 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 and I'm left with just 1. So this number, 10n minus n, is just equal to 1. Right? Now, remembering back to your algebra, what is 10n minus n? 9n. We have 10 lots of something, which is n, 10 lots of n, take away 1 lot of n, and we're left with 9 lots of n. So it's actually 9n equals 1. Now, remembering again back to your equations, how do I get, we've got 9 times n. We've got something multiplied by n equals to 1. How do I get this n on its own? What do I do, guys? Yeah, you divide both sides, and that makes the 9 go over to the other side. So divide this by 9, divide this by 9. That means these 9's cancel out. I'm left with n equals 1 over 9. Now we have something we have to conclude. N is equal to 0.1111. But n is also equal to 1 over 9. What's my conclusion here? What's my conclusion? That n is equal to this, n is equal to this. What can I conclude? Yeah, that's true. I know that here. What can I say about 1/9 and 0.1 repeater? That's right. That's my conclusion. Therefore, 0.1 repeater is equal to 1 over 9 as a fraction. Yeah, I just proved that. That's the working, because you see here, n is equal to this, and n is also equal to that. So they must be equal to each other. Okay, write down this working, please. And then I'll give you a little bit of a... Convert 0.54 repeater into a fraction. So again, the same method, we start with n equals 0.5454 repeater. That's our first step. How many digits, Nelson, are there in the repeating pattern? There's 2 digits. Is there 2 digits in the repeating pattern? Yeah, because it's 5, 4 repeated over and over again. So 2 digits in the repeating pattern. In the repeating pattern. So we multiply n by 100. So what I'm going to do here is say 100n equals what? What's 100 times its decimal? 54.5. Yeah, we shifted 2 decimal places, and so it's 54.5454. Dot, dot, dot. Sorry? Oh, it could be any letter. I'm just giving it like a symbolic name, like X or N, anything like that. You can use C, name, or whatever you like. So now I'm going to do the same thing. I'm going to do 100n minus n. But if I go over here, if I do 54.5454 minus 0.5454, you see here that what happens is the 4's cancel out. 5 minus 5 is 0, 4 minus 4 is 0, 5 minus 5 is 0, and then we're just left with 54. And so this number minus 0.5454, that's equal to 54. That's what we said here. What's 100n minus n? 99n. It's 99 lots of n. Okay? Now, if I then say I've got 99n equals 54, how do I get the n on its own? What do I have to do? Divide it by 99. Divide both sides by 99. Right, and so n equals 54 over 99. This actually simplifies to being 6 over 11. Okay? It doesn't always simplify, but you can divide top and bottom by 9 to get that. And so that's the way we do it. Now what I want to do is, instead of doing another example, looking at the time, I'll go back up, I'll just show you, I'll just put some questions up which I would like you to do.